Hello YouTube, and welcome back to another video. Last time we went over scene hierarchy, where we learned how to manipulate and traverse amongst the scene, and also learn more about JSX, and what it means to use JSX for a scene hierarchy, and to not use it. We've learned about modifying the hierarchy, we learned about a whole bunch of stuff. We're even querying the hierarchy. And if you want to learn more about any of this stuff, please check the last video. There'll be a playlist somewhere. Okay. In this video, we'll be learning about positioning. So in this case, positioning will allow us to move the components all around the screen. We'll be able to manipulate them, such as you see here. But we've already done positioning a little bit. If you look at the previous example that we've done, you can see that we have 5 rectangles going up and down, but then we have a height, a width, their X is being manipulated a little bit, and we're also changing the position down here. So let's learn more about that in today's video. If we look at this video, for example, or this example, if we look at the source code, and I'm going to, I'll just click here. And what we can see is if we go back to this one, we can see how there's grid lines. The grids are rotating. You have this half circle or semicircle outside. You have this inner circle, and then you have 2 arrows. The whole thing is moving as one, as a unison. So let's look at the code for that. So you have your red, blue, and green. You're making a group, create ref, which is a node, and you're scaling it. Okay. So then we start it with a node. We have our grid. So it looks like grid is an actual item in Motion Canvas. So you have your spacing, your strokes, your line width, all of that. And then you have your first circle. And then you can see that there is a start angle and an angle, and it's a blue. So if we go to our example over here, you can see that this blue circle is what we're referencing. And you can see that we have a scale. Our scale is 1 for all of it right now. Line width, start angle, end angle. Then we have our line, and it points in a direction. Same thing with the other line. And then we have the circle in the very middle. So then for the animation part, we have group position X is 100 and then 0.8. And actually, to make this a little bit easier to go through, let me comment out my previous example, copy this raw file, and let's actually play with this a little bit. I find it's useful to play with the different animations to learn a little bit more. So if I remove the yields, you can see what we start out with. It's just a plain basic circle or grid layout. If I add the first one, nothing happens. Why does nothing happen? Let's actually run it. So if we look at the full picture, the full animation, it moves to the right, it turns, it scales, moves to the left, and then scales back, or unscales. So this first yield part is moving the whole group in the X direction. And we got group because it is create ref of node. This whole thing is in the node. So it makes a reference to this. So you have the create ref is of type node because we're using TypeScript. And the group is located right here. And we want to start the whole group. So if I stop this, I put it at the very beginning again. You can see we're a little off the center. We're -1, 100. And we reference our group by here. And then we want to say, hey, take this entire node, this entire group, shift it by 100 to put it in the center. And if we look at the actual stuff, or the actual things that X can do, the first value is shift it to position 100. So we're going to go from -100 to 100. And if we look at this statement down here, it uses a Cartesian coordinate system with the origin located at the center of the screen, with the x-axis going to the right and the y-axis going down. So that would make sense. So 100 is over here, or -100 is over here, 100 is over here, and you can actually see in the upper left-hand corner where the actual coordinates are. So we can look right here, and we have basically 0, 100, -100, and then over here we have about 0, 100. So if I play this, it should go all the way over to here, and it does. And then the other part is in 0.8. So I believe that's 0.8 seconds. Let me see. It doesn't actually say, but I believe that's in about a second. It does that. The next one is rotate it 30 degrees in 0.8 seconds. And again, we're doing the whole group. Then we want to scale. And we're scaling the whole thing. So scale is right here. And it looks like we're calling the scale function. We have a create signal. We haven't really talked about create signal yet. We will see what it does. Maybe create signals in this chapter that we're going to be going through. But it looks like we changed the scale from 1, I'm assuming, to 2 in, again, 0.8 seconds. And then we want to scale, and then back to -100, which where we began, in 0.8. And then remember all from our previous lesson, we are going to be doing this part and the second part at the same time. So we rotated it from our starting position of 0 to 30 degrees. Now we're going to rotate it back to 0 and scale it back to the original scale at the same time. So you'll see it'll rotate, zoom in, shift, and then it'll rotate out at the same time. So this is what you can do with positioning. You can move and manipulate different items. So let's see what this lesson entails. And hopefully we learn about create signal. If not, we will cover it definitely at the end of this video if we don't do it beforehand. So as mentioned, we have position, which, as we can see, you can do position.x or position.y. Okay. And we have another example here where we have a node with position 1, 2. We have another component. You can also do the same thing of x equals 1, y equals 2. So either position with an array or an x and y with individual numbers. Then you can do node.position to get that. Or you can do, so that would give you the vector. Or you can get the individual component. Vector would be 1, 2 instead of just 1. Setting the position, you can do node position, and then this kind of sets it. So if you don't include it, it'd be a getter. If you include it, it'll be a setter. If you need an explanation between getter and setter, please leave a comment below. I will right away answer that. And if you want examples, leave a comment down below. I will answer your question and I'll give you an example in the comments below if you have a question. So then we have, or you can do a arrow function as well if you want to use vectors, or you can do individuals and you can either use an arrow function or you can use a 1. Why would you use an arrow function? If the position is a little bit more complicated and you wanted to have a whole function to calculate and determine the position. Maybe you're doing something complicated or not, is up to you. Next we have scale, and as we saw in our example, scale, we have the scale by 2 and 0.2. And we have our scale, node.scale, node scale x. Now, what's weird with this example is scale actually creates signal. So we still haven't went over what it is. It seems like scale is a built-in thing to motion canvas, yet we don't use it here exactly in the way that the example shows. But in a similar way to position, you can use it. Same with rotate, in a very similar way. Absolute transform. Each of the basic transform properties, which you have gone through already, has a dedicated helper method that operates in world space. This can be helpful, for instance, when we needed to match the transforms of the two nodes located within different parents. Consider the following example. So we have a circle. We have circle A. And it looks like we're creating a reference of type node. Seems like everything's a node. So everything inherits the node object. So we have circle A, which is right here. Circle B, which is right here. And we have circle B, absolute position, is of circle A, absolute position. So this can be helpful, for instance, when we need to match the transforms of two nodes located in different parents. Okay. We access the absolute positioning world space of circle A. So we get the position of circle A and we set it to be circle B. And so what you'll see is two circles on top of each other. We'll still need to set the absolute position of circle B and not just the position. It may seem redundant since circle B is a direct child of the scene view, but the local space of the scene view is not the same as the world space. So this must be the position 1, 0, which is in the middle of this node. That would be the relative space. And then this would be in absolute space. So this is 10, 0 relative to what our original node's position is in. Let me see if I have... Okay, so I do have some circles there. Let's see if I can actually demonstrate this to make it a little bit clearer. So if I have my circles here. Okay, so I don't have... Here, I forgot to include it in my function. So let me paste it in the correct location. Sorry about that. And then if I place this in the correct location, let's put these, we'll put them up right here. No, right here. So I have my two circles. So if I look at my circles, I have my white circle, which is over here. And you can see that, oh my goodness, I don't need the inspector. Actually, yeah, I'll click on this one. So you can see it's at 200, 200. So that is adding 100 over to this position, which is why it's there. And then this one is in 1010. So if I click on this one, it's about 1010. I know this says it's hard to get exactly there, but trust me, it's there. And if I use the other line and I add it to my logic and I save it, you can see that now circle A, which is the white circle, is now at the same position as circle B is now the same position as circle A. Circle B is the red one, and if you remember from again the scene hierarchy, this is first, so it will be printed on the screen first. This is the second item, so it will be printed on the screen second, so it will be on top of the first item. And that is why we see the red, our second item, on top of the white one. If you have any questions, leave a comment down below if it's not clear. So that was absolute position. We have absolute scale, which is the same way. Absolute rotation. And now we have matrices. So this goes back in your algebra class from high school or college. For more advanced users, nodes expose all of the matrices necessary to map vectors from one space to another. For example, the helper property described above could be re-implemented using the world to parent and local to world matrices. So you can see node.absolute position is the same thing as vector2.0.transform as point, and inside has node to local to world. And then like the other one, world to parent. Local to world gets the local to world matrix for this node. This matrix transforms vectors from the local space of this node to the world space. So there's the example. And same thing with world to local. There's the example. Local to world, parent to world, world to parent. With this, we now have everything we need to know when it comes to moving different positions. You got your X, you got your Y. You can scale different things. So right here we have vector 2 upscale. I didn't even notice that before, but there's another example. Yeah, that's everything there is to know about positioning. If you have any questions or comments, make sure you leave them in the comment section below. Aside from that, if you do like this series, please hit the like button. Please subscribe. I'm going to be going through the rest of these pages in the coming videos, and then I have something special planned afterwards. So please stay tuned, and I will see you in the next one.